Security isn't an afterthought. It's part of every phase of your software deployment lifecycle, from writing code to deploying infrastructure. Imagine you're responsible for a mission-critical GitHub repo. You wanted airtight protection, but you also want your team and your open source community to feel welcome. Strict security policies can introduce friction, slowing down the development and collaboration at times. I'm Michael Michal, and in this session, we will cover recognizing why securing your repository early, shifting left, is critical to catching vulnerabilities before reaching production. Identifying GitHub security tools and best practices, from gitignore to automated dependency update, these are some of the backbone of the proactive defense strategy. How we can keep sensitive files out of your repo by mastering gitignore and the different patterns and workflows with it. How we can detect and remediate vulnerability dependencies with Dependabot and manual reviews. And how we can leverage advanced features such as code scanning and secret scanning to surface hidden risks and protect your secrets. These skills will empower you to build a secure deployment pipeline that guards your code without slowing down your team. So let's get started. GitHub security can be simplified into 4 key stages: prevent, detect, respond, and govern. We start by preventing issues through secure code practice and access controls. Then we detect vulnerabilities using tools like Dependabot and code scanning. When something goes wrong, we respond by fixing the issues and removing sensitive data. And finally, we govern. We govern security at scale. We use policies, rule sets, and audit logs. This life cycle will guide everything we cover in the rest of this session. Next, let's go to security. Security in GitHub operates across 3 levels: repository, organization, and enterprise. At the repository level, we focus on secure code through things like branch protection and scanning. At the organization level, we introduce team management, access control, and policies like rule sets. At the enterprise level, security expands to include governance, compliance, and monitoring through audit logs. As we go through this session, you'll see how each level builds on the previous one to create a complete secure model. Security is critical because protecting data and preventing breaches is a core responsibility in modern deployment. A strong strategy focuses on ensuring only authorized users have access, and the data is only modified when appropriate. There are 3 key areas to consider: education, since security knowledge evolves, secure coding practice, and compliance with regulations. Most importantly, security must be part of the entire deployment lifecycle, not something added to the end. This is where the concept of shifting left comes in. Addressing security early in the development to reduce risk and rework is much better. Embedding security early leads to faster, safer, and higher quality software. Code with security in mind. Code defensively. The same thing with managing your GitHub environment. We want to build, manage, and introduce all the different aspects that can help our developers build with security in mind. One of the simplest ways to prevent security issues is to avoid. We want to avoid committing any sensitive data in the first place, and that's when we use .gitignore. This file excludes files like configuration files, build output, and secrets from being committed. One example of using it is, let's say you're building code that connects to a database. Part of the connection to the database, maybe you're using a secure key strings or an API or some sort of a security code. You don't want to accidentally commit that file to your production. You're only using it for testing. So all you do is add that as an exemption, or don't allow the commitment of that, or the committing of that file in your gitignore. Now remember, gitignore is not a full security control. It helps really prevent mistakes, but it can be bypassed. So if sensitive data is committed, it must be treated as compromised and handled properly. Branch protection is one of the most important controls for preventing security issues. It allows us to enforce rules on critical branches, so requiring builds to pass and review before code can be merged. So for example, if I am building a certain feature or editing or fixing a bug in my code. By setting branch protections and requiring reviewers, I will only be able to submit or merge that branch that I've created after multiple different validation. This ensures that every change is validated, and it can be validated automatically by other users, or it can be involved through tests. So I can, for example, enforce that every time I set to merge or I set to add my code to something, it's going to run some sort of a validation program or wait for another reviewer to approve it. You can also advance controls by requiring these code reviewers. This way, I will prevent authors from approving their own changes. That means if I am a code owner and I am reviewing, I might separate who is building the code and who is reviewing the code on two different groups. So let's take a look at the code owners. Code owners define who is responsible for specific parts of the code base. So when changes are made, the right people are automatically added as reviewers. This ensures that the subject matter experts validate important changes before they're merged. It improves both the code quality and accountability and starts to introduce governance into the development process. We can also implement rule sets. Rule sets takes what we've seen with branch protection and scale it across the organization. So instead of configuring those rules on one branch at a time, we can group them into reusable policies and apply them consistently across multiple branches or across multiple repositories in your environment. This helps enforce a standard like required reviews, status checks, and commits. This way you can commit signing at scale while still allowing controlled exceptions when needed. This is our first step into repository level security. And moving from a repository level security into an organizational level security will provide us with that organizational level governance. Now that we introduced both branch protection and rule sets, let's take a look and compare them. Branch protection works really well for individual branches, but it's limited when managing security at a scale. Rule sets allows multiple rule groups. They can be enabled or disabled easily and are visible across the organization. The key advantage is that rule set let you layer policies and enforce the most restrictive settings consistently, making them more flexible and scalable for larger teams. In short, branch protection, it's per branch. Rule set, reusable across many. Their flexibility, so you can turn on off a rule set, you can test the policies. Not just admin-only visibility. They give you that transparency, multiple users will be able to see them. Now that we've covered how to prevent issues, let's look at how GitHub helps us detect and manage security risks. The Security tab is the central place where teams can monitor vulnerabilities. They can manage security policies and respond to issues. It includes features like Dependabot alerts and code scanning and secret scanning. All are integrated into your development workflow. This allows teams to continuously identify and address risks without slowing down development. Modern application relies heavily on open source dependencies, which can introduce hidden risks. GitHub automatically builds a dependency graph. This will show you all the libraries your project depends on, including nested dependencies. Dependabot continuously monitors those dependencies and will alert you when a known vulnerability is detected. This gives your team visibility into risks and help them respond quickly before issues impact production. Dependabot doesn't just detect vulnerabilities. It helps you fix them automatically. So when a vulnerability is found, Dependabot can generate a pull request with an update secure version of the dependencies. It's already monitoring that, so it knows that there's a problem with it and knows how to fix it. So teams can then review and merge the update through the normal development workflow. So it creates the pull request, but gives you the ability to take a look at it before you actually go ahead and automate it or run it. This approach will combine control and allow teams to remediate issues quickly without sacrificing code review standards. So we're still reviewing, but we're fixing the code faster than actually doing the entire thing step by step from scratch. Beyond dependencies, GitHub also helps you detect issues directly in your code and sensitive data. For example, code scanning. It analyzes your code base and identifies any vulnerabilities and any code issues early in your development process. Secret scanning focuses on detecting exposed credentials, such as those API keys that you've used to access the database, or tokens that you are having in your code. They can even block them from being committed. Together, these tools help protect both your application and your sensitive data before issues reach production. So, code scanning looks at logic vulnerabilities. Secret scanning looks at exposed credential. They both happen early before the deployment, so early detection is key for both of those tools. And not just alerts, it can prevent commits as well. Now that you've seen how GitHub detects issues, let's look at how we respond when something goes wrong. Once vulnerabilities are detected, it's important to have a clear process of how are we going to report them. The security.md file provides guidance on how contributors and users can report security issues responsibly. So instead of exposing that we have a vulnerability publicly and anybody can read about it and then creating more risk, we are creating the right communication channels, issuing exactly what needs to be done when there is an issue with my project. And how are we going to report it and how are we going to fix it? Security advisories provide that structure. It provides a structure for you to manage vulnerabilities from discovery to disclosure. So now teams can collaborate privately to investigate and fix issues before sharing them publicly. Once a fix is ready, the advisors can publish them to inform the users and the broader community. This process helps you balance transparency with protection, ensuring vulnerabilities are handled responsibly and efficiently. You can share details through what we call a CVE databases. This is how internal advisors will be able to communicate together on the best approach. Now, let's put everything that we learned together about dependency and security into practice. You have the following exercise. It's available for you on aka.ms/learn-gh-100. So let's practice. Great work making it to the end of this module. Now it's time for a quick knowledge check to reinforce what we've learned. Let's dive in. What's the best way to make sure you are integrating the most secure versions of your project dependencies? Configure your project package files to always use the latest version of dependencies. Check each project security details closely before adding it to your dependencies by confirming its version, status across multiple advisory sites, or enable Dependabot for your repository. And you're right. The correct answer is enable Dependabot for your repository. Suppose one of your source projects relies on secrets kept in a folder called .secrets. You would like to make sure that the files kept in this folder on development machines aren't inadvertently committed to the repository. Which of these files best help enforce this policy? Security.md, .getignore, contributing.md. You guessed right. It's B. .getignore. What does secret scanning do? Looks for known secrets or credentials committed within the repository, analyze and finds vulnerabilities and errors in the code in a GitHub repository. Secret scanning uses CodeQL to query your code as data. Looks for known secrets or credential committed within the repository. In this session, you learned why securing your GitHub repository is critical and how shifting security checks left in the development lifecycle help you catch issues early. We reviewed essential security controls like .getIgnorers. We looked at Dependabot alerts and dependency graphs to detect vulnerability packages and advanced checks such as code scanning and secret scanning. Armed with these best practices, you maintain a robust, developer-friendly security posture in your projects. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.